Welcome to screencast session on week 7 interval scheduling. This interval scheduling algorithm we are implementing using the greedy approach. So as you know that the greedy approach is making a sequence of choices to achieve that optimal solution. The optimal solution might mean that it could be that maximum or minimum value for your problem. So let's do the implementation in two parts. The first part of the function we are implementing is sorting a tuple. So in this particular interval scheduling, so we have the tuple value with three values of that. So the ID of the classroom, starting time of it, and at the same time that the finish time of the class. So there are multiple requests are coming for a single classroom. We want to schedule the classes without any collision. So let's do that. The tuple sorting. So for the tuple sorting, already we have received a tuple, that's L, that's called list of tuple values. So in this, the index also we are receiving. For the sorting purpose, we are trying to sort. So based on that, the finish time of the class. So for this, we are bringing the values in the index position of 201. So let's do that using iteration. Each tuple value we are getting from the actual list taken as a parameter. In this, we try to bring the values in this particular way, that is appending of it. A new L dash is created, that is T of index 2 index plus 1. So index 2 index plus 1. So that second index value we are getting. So then after it, we try to get it that the T of that from the tuple, we are trying to get the value up to the index, so that you are trying to get it that 0th one and first one. So we got it. So then we are trying to sort it, that is L dash is going to be sorted. So when that L dash is going to be sorted, we sort based on that tuple. So finish time value. So finish time value we are bringing anyway, it's a first value. Again we are bringing that L dash to some other list. For that we are using another one as L double dash, which it contains the empty list. Again we are using iteration. So using that L dash values which are available, we are bringing the values into that first index, 0th index and second index. For this, so L double dash dot append. So now we try to bring the values back, that is T of that 1 to that index plus 1. So that's 1 to index plus 1. Then the second one is that 0 to 1, that means 0th value only, that is 0 to 1, that is 0th value only we are getting. So then we are trying to get that second index value, that is 2 to 2. So we got the tuple back, and then finally we try to return that L double dash, so which is sorted based on the finish time. So this is a supported function for interval scheduling. So let's do the interval scheduling, the actual implementation of the algorithm. So where it is getting a sorted list, so that is from the tuple sort function which is available in the above, where L you are sending the index of the last, the particular finish time view, that is you are using is 2. Then initially the first class is going to be accepted because it's already sorted, accepted. So that is sorted off the sorted list of, so 0 and 0, which is that first job we are trying to get it, the first job one. And then initially the first class is scheduled, then we try to check that remaining classes. For this there is iteration, that is I and S and F. So where the tuple contains three values of identification of the class, and it is having that, so the starting time of the class and as well as that finish time of the class. So in this iteration we try to get it. So here we try to get it. So if and only you are allocating the particular latest class, the room. So when the latest class or new class start time is greater than that last finished class end time. So for this we are checking that if S is greater than, so the list of classes whatever accepted so far, the last one, so which it's second tuple value is nothing but that finish time. So if the new class start time is greater than that completed class finish time, then we try to accept it. So that accepted, we are trying to append it. So accepted of that append. Now we are appending that I. So we are appending that one. Then finally we try to return the list of that accepted classes. So this list of accepted classes is a list that is returned to your main code. The main code, what it is doing is it is calculating that length of the output value. So that list length is going to be written. So let's run this. Yes. So out of these all particular classes like 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 classes or 9 requests are received to allocate a room. So out of that, only 4 classes are scheduled at maximum without any collision. So that is called greedy method. Hope you understand. So thank you very much. Have a nice day.